Hi, everybody. Good morning. And thank you for joining ESOA's all-female showcase session on Project Darwin, where we are going to be talking with Ines Sanz from Hispasat and Daniela Petrovic from Telefonica about the evolution of next-generation vehicle connectivity. Let me start by introducing my colleagues to you. Ines is responsible for customer engineering and technical solutions at Hispasat, an important ESOA member that operates 9 geostationary satellites using the KU, the KA, and the C-band, with coverage over Europe and the Americas. Ines is a physicist with an MBA, and she's also responsible for the management and development of technological R&D projects for the Hispasat Group, which includes representing the company in international fora like DVB, ETSI, and so on. Welcome, Ines.
Thank you. Thank you, Aarti.
I'd also like to introduce Daniela. Daniela is co-founder and delivery director at the Darwin Innovation Group, which means it's her job to shape and deliver the strategic vision of Project Darwin that we're going to hear about today. She's part of the strategic innovation team at O2 as well. And Daniela has quite a few degrees in engineering, in strategy, in public health, and insurance. I hope I haven't missed anything, Daniela, but suffice to say that there's probably nobody better qualified than you to be the delivery director at Darwin. Welcome, Daniela.
Thank you, Aarti.
So as ESOA, we like to showcase all the good work that our members are doing, and we like to bring attention to their partners as well. The essential role of satellite to enable diverse 5G use cases is becoming increasingly clear, and Project Darwin is a great example of that. We're going to first show a very short video about the project. Excellent. That was great. So we saw in the video that, of course, this project uses not only satellite communications, but imagery as well. But we're going to focus on the communications part today. And if Jordan can bring up the slides, I'm going to hand over to Ines and Daniela to tell us more about Project Darwin. Before Ines starts, I'd like to invite all of the people watching to please post their comments and their questions in the chat. We will get to them after the presentation. Over to you, Ines.
Thank you, Aarti. I would like to share with you a presentation, please. First page. Okay, thank you. First of all, I would like to thank Aarti and the organizers for the kind invitation to participate in this interesting panel to share Hispasat vision about a connected and autonomous vehicle, as well as our participation in the Darwin project with Telefonica, one of our most important partners and clients. Next, please. To focus our discussion and to understand the Darwin project origins, in this slide, we have a general representation of the different connectivity technologies, fiber, cellular, and satellite. and their degree of deployment depending on the type of territory. We see how fiber and cellular cover from urban, suburban, and partly rural areas, while the satellite covers all of them. That means that satellites provide coverage where terrestrial infrastructure either doesn't exist or doesn't have enough capacity. Next, please. Satellite global coverage is a very important advantage for the autonomous connected vehicles that need to be permanently connected no matter where they move. Other relevant satellite communication advantages are easy to deploy. The coverage is available as soon as the satellite is in service. No need of additional terrestrial infrastructure. Security and resilience. Satellite communication are designed for secure and resilient operation. Because of its centralized architecture, satellite networks can operate offline to terrestrial networks, being the ideal means of deploying secure networks as well as to act in case of emergency and disaster recovery situation, for example. And finally, efficiency. Thanks to the multicast broadcast capability, applications such as SOTA, which is software update over the air, it can be performed efficiently, quickly, and securely. Here are the main reasons why Darwin project focuses on satellite communication. Next, please. We see in this picture an example of a high-throughput satellite multi-beam coverage, where the architecture is very similar to terrestrial cellular networks. You see, in this case, the satellite transparently connects to the user terminals, in this case, connected vehicles, for example, to the gateway station, where a connection to a cellular base station or a network terrestrial capability could be located. Next one, please. Here is a summary of some satellite application for mobility. SOTA, for the connected car, software update over the air, logistics and fleet control, as well as on-flight entertainment for passengers. Integrating the satellite into the 5G standard will facilitate the development of this and much more application. Next one, please. This is the situation in 3GPP. Satellite is already present in the 5G 3GPP roadmap, mainly from release 16, when different use cases were analyzed, and specifically from release 17, where started the regulatory work on 5G new radio specs to incorporate non-terrestrial access networks as satellite geostationary and non-geostationary, and also hubs. Next, please. This picture represents connectivity scenarios between terrestrial networks and non-terrestrial networks for 5G mobility applications. We see here how ships, aircrafts, and medium high-speed terrestrial vehicles and trains are connected to different types of base stations, outdoor terrestrial if available, or through different types of satellites, geo and not geo. In the table, some use cases examples are described: data rate, user terminal density, maximum speed, and the environment. In the case of vehicles, 50 megabit for download is considered, and 25 megabits for upload for vehicles at 250 kilometers per hour and low population roads. This information is coming from a 3GPP technical report. Here is the information. Next one, please. And now this is time for Daniela to explain Darwin's Satcom Labs. Mm-hmm.
Thank you, Ines. So this Ines' story leads me nicely to the story about Darwin and the reason we created the lab. The lab is based at Harvard campus, and the latest addition to the lab is a new lab in Malaga, where we are going to explore all of the possibilities of 5G and satellite communication in a combined channel. So what we are exploring with Darwin is a use case of connected autonomous vehicles being connected in real time anywhere on the planet by using both communication channels, the terrestrial and satellite. And how we are doing that, we are switching between the two channels. And as Ines mentioned, we are checking the level of terrestrial signal and with agreed levels of quality of signal, we come to a certain threshold and then switch to satellite and vice versa. The idea is that we keep on sending information about the car performance at all times. Why is that important? First of all, it will inform regulators and insurance companies that will help these connected autonomous vehicles to be a mainstream category. So by doing this, we are looking at particularly traffic utilization and what type of telematics data we can send from terrestrial or from satellite channels. This work in the last 2 years resulted between Telefonica, Hispasat, supported by European Space Agency and UK Space Agency, resulted in two patents that were filed about this particular solution. The two international patents were filed on the hybrid user terminal. So that is the terminal that sits in the connected autonomous vehicle and switches between the two communication channels. And the other patent is related to the backend architecture. This is where we converge the information of network and IT in provisioning, billing, and charging in the backend architecture from both Hispasat and Telefonica. And this completes the end-to-end solution in order to help us move to the mainstream of connected autonomous vehicles as a service. If you could move to the next slide, please. As I mentioned, European Space Agency and UK Space Agency played an important part in development of Darwin. Our lab is based in Harvard campus in the UK, and there is UK Space Agency and European Space Agency is also based, and there is a good collaboration happening between Darwin and ESA. There is on the slide here, you see the latest addition to ESA UK of a 5G demonstration lab. Our lab, which is not far from this lab at ESA, is actually combining 5G and satellite communication, and we have plans to connect the two labs with a corridor. So these are the next steps at Harvard campus. We also want to expand our work in Spain, and we recently opened Darwin Innovation Lab in Malaga as well. And we want to simply replicate the same concept in Spain. Next slide, please. As you can see, here are the partners, and we presented in a number of shows and conferences where we enable the members of public to experience connected autonomous vehicles. We showed the equipment we use, and we also collaborate very closely with universities, University of Oxford and University of Glasgow. And in the coming months, we are also adding additional academic institutions to our partnership program. Next slide, please. So as previously mentioned in Ines' slides, this is what we are trying to achieve. So we want all of the vehicles that, we branded Darwin as connectivity for mobility. So what we want to achieve is to enable vehicles. So here we are talking about land transportation. We are talking about farming vehicles, agriculture, mining, and maritime. So we are, but our main use case is connected autonomous vehicle. The reason for that is that there are other projects that we are learning from in land transportation, like Ines will talk about Renfe project that was done in Spain on trains. So these are all the projects that we are learning from, but the biggest novelty of Darwin is implementing this learning in the use case of connected autonomous vehicles. Next slide, please. So we developed, as I mentioned, and filed patents for critical technologies. What is important to add here is that we created a roadmap, so we follow closely the development of standards. So as standards develop, they will inform our solution, and hopefully our solution with the continuous testing will inform the standards. So we work very closely with standardization bodies and following the development there. What we also developed as part of the Darwin project is data acquisition and control device, which is really traffic optimization for telematics data. So we are here testing what is it that is super important to be sent from the car for regulators, for insurers, and for all stakeholders in the connected autonomous vehicles ecosystem, to be able to help us to move this concept from test beds into the mainstream, into public roads. Next slide, please. Over to Ines.
Thank you, Daniela. This last slides, please, next one, because it's just the introduction. To some examples to illustrate the current deployment or development situation in terms of SATCOM terminal. Here we have 3 examples of flat panel satellite antennas technology. First one is one K-Meta, which is now available in the market. It's the first model in KU. We test this technology on a vehicle in Madrid with our satellites, geostationary satellites, with very good performances. The test during the test, we see data rates up to 56 megabit in download and about 6 megabit in upload, which is very good. And the other phased array technology based on 5G beamforming is very promising. With new generation of ASICs will improve efficiency and reduce power consumption. We hope the first models will be available for testing beginning next year. And next one, please. We will finalize with conclusions. First one is that satellites offers important benefits to 5G ecosystems, such as security, reliability, multicast, broadcast capability, and global coverage. Satellites also complement terrestrial infrastructure and are essential for mobility to provide support to autonomous connected vehicles. Darwin Satcom Labs will contribute to complete an end-to-end solution for the connected and autonomous vehicle ecosystem, integrating satellite and terrestrial systems like 4G, 5G, to ensure coverage. And finally, mobile network operators involvement like Telefonica is doing here in Darwin project is essential to achieve a complete and efficient integration of satellite into 5G ecosystem. And here we finalize our presentation, and Aarti, is your time now.
Brilliant. Thank you so much. That was very interesting. I'm going to remind participants to please continue to post their questions in the chat box. I'm going to start, however, with a few of my own. So it's great to see here, not just both that I have two lady colleagues, but also that we have satellite and terrestrial. Now, ESOA spends quite some time engaging with MNOs. We have a collaboration with NGMN, the Next Generation Mobile Network Operators Alliance. But in our engagement, we often have the sense that mobile operators are waiting for LEO broadband satellite systems to arrive in order to enable key 5G use cases. But Darwin, as you just explained, relies on Hispasat's geostationary satellites. So Daniela, I wanted to start by asking you, how satisfied are you with the service?
Well, first of all, I would just say that we are the collaboration between Telefonica and Hispasat is not started only in this project. That there were other projects that the collaboration is happening. I mentioned ramp-fed trains, for example, in Spain. Darwin is exploring geosatellite communication and what the antennas and the devices that that Ines mentioned in the presentation are all devices that we are testing in the lab. So we keep on testing different devices from the current manufacturer and combining them with our solution and fine-tuning our solution to the devices. What we are finding so far, the results are very, very good. So we are very pleased with geosatellite performance when it comes to connected autonomous vehicles and telematics. As I mentioned, it's very important that we do the traffic optimization when we are switching from one channel to another, and but we are even exceeding the expectations in terms of performance from GEOS.
Excellent. Ines, do you want to add anything on that?
Yes, latency is a requirement that must be examined in the context of an end-to-end performance for given services, because latency is probably one of the points for GEO satellites. Many applications can cope with geo latency by using mitigation techniques to overcome these effects. For example, for internet browsing, video conference, software update over the air, whilst others, particularly in real time as gaming, are more sensitive to latency and therefore designed to work on low latency networks. Nevertheless, geosatellites can be a solution. LEO satellites will help when they are available, of course. It's a combination of geo, LEO, terrestrial, all the infrastructures are welcome for the 5G ecosystem.
Mm-hmm. Great. Okay. Let's turn to one of the questions in the chat. I want to look at Mohanned's question, Mohaned from Intelsat. He's asking what work is being done to enable a connected car to communicate between a terrestrial and satellite network. And he's also mentioning trains, and that actually brings me to a point that I wanted, because this is, of course, not the first mobile connectivity project where both of you have worked together, where Hispasat and Telefonica have collaborated. You also worked with Renfe in Spain on high-speed train connectivity. So what lessons did you learn from that cooperation that have proved relevant to Darwin? Could you take that question and Mohanned's question? Who wants to go first? Please go ahead.
For me, Aarti, that's a very good question. Our experience with Renfe project has been very interesting for Hispasat. We learned a lot about rail world together with Telefonica. And this experience applies in some cases to Darwin project and the connected car. For example, the need to develop a more compact satellite terminal, satellite antenna, which is specifically designed for the different verticals or vehicle characteristics, also to develop a new system which for traffic shaping and bandwidth aggregations to add dynamically and efficiently the satellite bandwidth to the terrestrial network as 4G, and etc.
Yeah.
Okay.
To add to that, I would say that we definitely learned from that project, and we are incorporating knowledge into testing of the new flat antennas in the connected autonomous vehicles market. What is important as we continue in our development is to miniaturize the hybrid user terminal that is switching between the two channels, so we can implement the solution in connected autonomous vehicles in a factory line, not as a retrofit solution. So that would really help that connected autonomous vehicles are in a mainstream and will grow connected autonomous vehicles markets in Europe. There are many activities, many test beds, as you know, that are testing this type of transportation. Where we believe that Darwin is going to help is really increase the confidence about having these vehicles on the public roads, and hence the real-time connectivity between the vehicles and the control center, where we receive all of the information, important telematics information about these vehicles.
Understood. Thank you. Actually, your point about mass production, mass market, and all of this is very relevant. And we know that there's important work on in the RAN group in 3GPP ongoing on new radio, and that will become relevant to integrating the two systems. So let me come to a question from David Bonner from technical officer from the US government. He's asking, for 5G phones connected to these systems, what will change? Will there be more data that the 5G phone will store? Will you get the GPS and the vehicle data like speed and maintenance, etc., linked to the phone? I don't know if either of you could take that question.
Well, I think definitely what we are trying to do with utilization of the traffic, because of the capacity, it is obvious that we cannot transmit the same amount of telematics data from CAVs when the information is channeled through terrestrial channel or through satellite. So we have to be clever in deciding what is that important set of information about telematics that we are sending over satellite channel. What we are doing is we are not losing the information that is not transmitted over satellite channel. We are buffering it, and once we go back to the terrestrial channel, we send the aggregated data. What is important here is that the subset of data that we are sending over satellite channel is good enough and tested with all insurance and regulators, different stakeholders, to be the most important subset of data for the use.
Great. Okay, that's very interesting. And also, look, I want to come back to one of my own questions. We know that security is absolutely key to getting connected and autonomous vehicles on the road, especially when, for example, we come at this from an insurance perspective. How relevant is satellite to that question?
I introduce as a important advantage of satellites in comparison with terrestrial networks, a small number of satellite gateways, few vectors for interception, and more control systems. Satellite networks can operate offline terrestrial connectivity, and it is possible to encrypt to a military grade, and I think these are the main elements for to provide security to the networks. Mm-hmm.
I would also add that part of Darwin project is an end-to-end cybersecurity solution. So what we are working on is connected autonomous vehicle cybersecurity solution, including terrestrial and satellite channels. So what Darwin team does, we are looking at all different intercept points in connected autonomous vehicle, and looking at how these points can be protected. So there is a constant and ongoing improvement in cybersecurity solution for connected autonomous vehicles.
Brilliant, thank you. Yes, it's true. We always talk about satellite as being important for resilience and stability of the system. I hadn't appreciated how relevant they also are, in fact, to the security dimension and the cybersecurity dimension. So thanks for taking that question. Moving on, just from a spectrum perspective, I know you are using, for the satellite side, Kymeta flat panel antenna today. Is the service designed for Ku band only?
No.
Question again from Mohamed at Intelsat.
No, currently Kymeta is operating in Ku, but some of the other technologies like phase array based in ASICs are the development is in parallel. Ku first, probably Ka then, but Ka will be also a good frequency band to provide more bandwidth, and as high throughput satellites extend Ka band coverage, this will be also an important frequency band. Ku is wide coverage, and to cover all the territory. In some cases, probably Ku is a right frequency band, and Ka now specific areas, and in the future also Ka for everywhere.
Exactly. Just to add to that, we are currently using in the solution. We are using Kymeta because it's the only one commercially available at the moment. We could utilize. However, we are also testing. The beauty of the lab is that we can test all other antennas that are sometimes coming from universities in beta stage, and we are happy to accept them and test the solution on these antennas. What is important is obviously the size of the antennas, so if we are to incorporate them on a factory line in the vehicles, they cannot be of the size they are now, so they have to be smaller and thinner, although we could see the huge development in flat satellite antennas. So I think that would be one of the steps, and of course the price of flat satellite antennas is still prohibitive to be incorporated in mass production. So there are two elements really where we need to consider when it goes to flat satellite antenna manufacturers, which is really the size. Obviously, the performance keeps improving, and we are really impressed with the performances we've seen so far, and the price point.
Excellent. Okay. Next question. I mean, let's come to the European Space Agency. Of course, ESA is playing a really important role in enabling the cross-sector collaboration between satellite and terrestrial operators. I know Telefonica and Hispasat have historical relations from backhaul in Latin America to the Renfe high-speed trains project and so on. But if we now look at the user side, because we're not just doing this to develop the technology, we're ultimately doing this to enable different use cases. Can you say more about the target markets for the connected and autonomous vehicles that are being tested?
Yes, so our target markets at the moment are land transportation and retail. So these are the initial target markets we are testing the solution in. We are exploring farming, agriculture, and mining. So these are the markets for connected autonomous vehicles where customers and end users are coming to us and asking whether the connected autonomous vehicle solution could be implemented in their setting. As we've seen since last year, logistics for retail became very important. So asset tracking and logistics traffic increased significantly. So retailers are very much interested in testing, trialing connected autonomous vehicle solution in their setting. And also we are looking at all land transportation options. We mentioned that we want to explore connected autonomous vehicles as land transportation in all areas, rural and urban. So, and that's where the solution helps. And we want to connect areas that have low coverage, and the solution will help there as well.
Great. Okay. Then we also had a question from Abdul Latif about spectrum sharing, because of course, on the one hand, we have important work going on either in projects or and demos and so on, which is not using 3GPP access, but then you also have the standardization work to enable integrated solutions, you know, truly integrated and seamless connectivity, all in one modem, one chipset, and so on. So does the fact that we're talking about integrated solutions automatically mean that we're also talking about spectrum sharing between terrestrial networks and non-terrestrial networks?
I'm not an expert in frequency sharing. In Hispasat, we have some expert. But from my point of view, I think satellite spectrum is we need to preserve a spectrum for satellites, as they need to provide services and to complement terrestrial networks. We need to keep our frequencies and to use it in the most efficient way.
Great. Okay. Daniela, do you want to make a comment?
Yes. So one of our, as I mentioned earlier, one of our patents filed as part of Darwin project is actually talking about a network slicing solution and how it could be incorporated in the future roadmap. So I think at the moment, with the solution that we have and with the current standard, we are pleased with the performance. However, as we move to release 17, we expect the performance to be even better. And the reason for that is that exactly that backend integration is going to be improved, and the solution itself will benefit from it.
Great. Okay.
Okay, Aarti, I would like to come back to your question about the frequency sharing between different uses. It is possible between fixed satellite services, for example, and fixed services, which is this is doing the past, but probably not for mobile services because it is ubiquitous and it is more complex.
Exactly.
Yes.
Okay. But what we are certainly learning is that integration is important. The long-term future of both technologies is absolutely important. So we have to find a way that both of them can continue to be relied on for this kind of service without actually causing harmful interference. So the answer on the spectrum sharing is no. I understand from your answers, not with the mobile service per se. Okay. Now, Darwin started as a European Space Agency supported innovation project. Your lab was launched formally about a year ago now, I think. What are the ambitions for its future? Where is this going?
So we are very ambitious at Darwin. We did start over a year ago, and we want to move this project forward and make it a commercial solution. So we are continuing to work in the process of offering commercial service of combined satellite and terrestrial services to the customers. So you'll hear I'm in the coming months our clear ambitions where we want to be. As I mentioned, that we started the service in the UK, and the service is our next market is Spain. So this is how we are going to move the solution, to replicate it to Europe, and our ultimate goal is to deliver the solution globally, and particularly in the Latin American market, where we see a huge need for such a service.
Wow, in the Latin American market. Can you elaborate a little bit on that? I mean, I know both of you collaborate there. It's also a very important market for Hispasat. But I didn't realize that would be such a market for this. Why is that? Can you comment?
You know, in Latin America, there are very wide areas in which there is no connectivity. Mm-hmm. And buses, for example, the connected vehicle is also a bus, which is traveling from one point to another point during hours without connectivity. And then this kind of services which are available now in Europe and in the first world, it is also there is a need to expand the service, and we need with the Darwin Lab development, probably we will reach new technology at a more attractive cost to provide services in connectivity, in buses, but also in farming, mining, and all of this. Connectivity is very important.
Yeah.
Latin America. Mm-hmm.
Daniela, any comment?
Yes, of course, the coverage is very important, and we are this solution helps with overcoming the challenge of low coverage. Mm-hmm. And of course, in the UK, as you know, the coverage is good, and as well as in Spain. So when we roll out the solution in the UK or in any of in Spain and other European countries, of course, there are areas where the solution is that everyone is going to benefit from them, but particularly the markets with low coverage, like Latin America, will benefit the most.
Great. Okay. So I think we are in our last couple of minutes. I want to ask you each to give me a 30-second comment on this question. Let's fast forward 10 years. Where are we on satellite, terrestrial, connected, and autonomous vehicles? Daniela.
Well, I would like to say that connected autonomous vehicles in 10 years' time will become mainstream, and we will see them as a service like any other service we take for granted today. And I believe that this solution and this collaboration will help us achieve that.
Thank you. Ines?
Similar. In 10 years from now, we hope some cars, fleet cars, will operate with satellite and terrestrial in a transparent way. Mm-hmm. Customers doesn't understand where the connection is made, if it is from terrestrial base station or if it is from satellite.
Excellent. Thank you. Well, with that, I want to thank everybody for having joined us. Thank you to Ines. Thank you for Daniela for animating this all-female session. I think we should do more of these. And I hope that everybody has enjoyed the session. And my main takeaways are that there's no barrier to satellite and terrestrial cooperation. In fact, we see with Project Darwin how critical it can be to actually make sure that connected and autonomous vehicles can get onto the road. And the future is up to us to create with that. Thank you both very, very much. Thanks to everybody.
Thank you.